In this video, we'll talk about two important things in ASP.NET Core, middleware and dependency injection. As we mentioned in the last video, the configure method in startup.cs is used to configure the middleware in the middleware pipeline. It's here. And the configure services method is used to register services for dependency injection, which is here. So what exactly do those things mean? First, the middleware pipeline. The ASP.NET Core framework uses a middleware-based architecture. Basically, the framework consists of a number of layers, and each layer is called a middleware. And this middleware forms a so-called middleware pipeline. As shown in this diagram, our application is usually at the end of the pipeline. When a request comes in, before it reaches our application, it actually has to pass through all the middleware before our application. Each middleware can process a request and decide either to let the request pass through to the next middleware or simply generates a response and bypass the rest of the pipeline. A similar process also happens to the response. When our application generates a response, the response goes back up the pipeline, and each middleware along the way can add or change the response. Conceptually, we can see the benefit of using this middleware pipeline architecture. It basically makes the framework easily customizable. For example, if we need certain functionality, we can insert a middleware into the pipeline. And if we don't need certain functionality, we can simply remove the corresponding middleware. This allows us to make the framework as complex or as simple as needed. If we look at the configure method in the startup class, we can see the default middleware added by the project template, which are exception handling, middleware to serve static files, middleware for routing, for authorization, and the endpoint middleware. The exception handling middleware will generate an error page if any exception happens in the middleware below. When a request comes in, if the request is for a static file, for example, if the request is for an image file or a CSS style sheet, the static files middleware will simply send back the file. This way, it will bypass all the rest of the pipeline. If the request is not for a static file, the routing middleware will parse the URL and decide which endpoint will handle the request. But before an endpoint can handle a request, the authorization middleware will check if the user has a right to access that endpoint. If not, the authorization middleware will return an access denied response and bypass the rest of the pipeline. If a user is indeed authorized, the endpoint middleware will invoke our controller action to process the request. As we can see here, the order of the middleware is important. For example, exception handling should be on top because there could be exceptions in all the other middleware, and exception handling should be the last one that decides on the response. Static files middleware before authorization means all the static files are effectively public, meaning anybody can access them. And the authorization should be after routing because certain access control is based on the URL and so on and so forth. So All in all, the order of the middleware is very important. Another thing we get from this example is that if we don't need certain functionality, we can easily remove the corresponding middleware. For example, we won't implement security until later in the course, so we actually don't need the authorization middleware right now. In the code, we can simply comment it out, and this middleware is removed from the pipeline. And if we run the code, we can see that it won't affect anything because we're not really using any authorization. Yep, it still works. So middleware and middleware pipeline are pretty easy to understand. The default middleware pipeline is good enough to get us started. Dependency injection, on the other hand, needs a bit more explanation. Let's start with this hypothetical example to motivate the need for dependency injection. Now, suppose we want to write a program that displays the information about an employee. The main method is simple enough. We just get an employee object, then print it out. The problem is that we'll need to get the employee from two different places. When we do testing, we'll get it from an in-memory array, but in production, we'll need to get it from a database. Obviously, the code to get data from different places is different. To get data from database, we may need to use EF core, and to get data from an array, it may be just as simple as using array index. So now we are facing a problem. For testing, we'll use a set of code, and for production, we'll use a different set of code. We certainly do not want to change the program back and forth and recompile all the time. So what do we do? Well, the common approach is to abstract the API for getting an employee object into an interface, then create two different implementations of the interface. The main program only needs to depend on the interface, and depending on the environment, we just supply the array-based implementation or the database-based implementation. This idea is sound. In our main method, we only need to declare a variable of the interface type, and the rest of the code will only depend on the interface, not a particular implementation. However, there's still one problem. We cannot instantiate an interface directly. We still need to say either new employee service here or new mock employee service here. So although we don't have to change a big chunk of code and recompile every time, we still need to change a small piece of code and recompile every time. This improves the situation but does not really solve the problem. This is where dependency injection comes in. Instead of the application code having to instantiate the objects, the framework will instantiate the objects and pass them to the application code, hence the name dependency injection. It's also called inversion of control in some literature because the control of instantiating objects is moved from application code to the framework. But dependency injection is a much more commonly used term as it's much more intuitive. Dependency injection in ASP.NET Core is actually pretty simple. There are just two things we need to know: service registration and the service injection. In service registration, we register a class under a certain type in the service collection. Here, we simply register a full class under the full type. It's also possible to register a class under an interface type the class implements or a superclass type this class inherits from. Here, the class simply registers under the same class type. Service injection is done by the framework, so we don't need to do it ourselves. For example, suppose we have a class bar, which needs a reference to an object foo. All we need to do is to declare a foo parameter in the constructor of bar. Then when a bar object is created using this constructor, the framework will use the type foo to look up the service collection and locate the class registered under foo, and then use this class to create an object and pass the object to the constructor of bar. Service registration happens in the configure services method in startup. We'll see an example in a moment to see how it's done. Another important thing to understand is that dependency injection only works among objects managed by the framework, but not all objects in the application. What this means for ASP.NET Core is that service objects can only be injected into controllers, views, and other service objects. Now let's see an example of registering a service object. This is the code that we used in the last video, and I added a couple of new things. First, I added a model class called employee, and this model class has ID property, name and the date hired, and also a property called supervisor, as well as a property called supervisor ID. If you remember Entity Framework Core, you'll recognize that this is the so-called navigation property, and this is the so-called foreign key property. Later on, we'll use EF Core to access database to retrieve data from database. So this is the model class, and I have a couple of constructors here, just regular constructors, no dependency injection or anything. The first one is an empty default constructor, and the second one takes a few parameters and set up some of the properties. This is just a regular model class, nothing too special about it. And I also created a service class here. And I thought I put it in a service folder, but I guess I forgot. Let me create the folder first. We'll say add a folder, we'll call it services, and let's move this one to the services folder. Okay. And let's change the namespace to services. Okay. So this service class is similar to what we discussed here. It contains an interface and implementation of the interface. So the interface here is very simple. It has only one method called getEmployees, which returns a list of employees. And we have one implementation of this employee service interface, and this implementation uses an internal list, and we created 4 employee objects, John, Jane, Tom, and Bob, and put them in the list, and we also set John to be the supervisor of Jane, and Jane to be the supervisor of Tom and Bob. And using this implementation, when we try to get a number of employees, it simply returns the employee list itself. Okay, so now we have the model class, the interface, and a mock implementation of the employee service, which in a real-world setting would be used for unit testing and so on. And the next thing is we want to register this as a service, and it's pretty simple to do. All we need to do is go to the configure services method in startup and put in something like services add singleton I employee service, which is the interface, and mock employee service, which is the implementation. So now we have done the service registration part. Note that here, the method we use to register the service is a generic method called add singleton. The first type parameter of this method is the type under which the service is registered, and the second one is a class for the service objects. These two are basically what we just explained before here. But what about the singleton thing? Well, in addition to service type and service class, there's a third thing related to service, and that's how long the service object will live, which is called service lifetime. Certain service objects can live as long as the application is running, and this type of service objects are called singleton objects, meaning that the whole application will only have one instance of this object, and everywhere this service is needed, they will get the same object. On the other end of the spectrum is the transient service objects. Transient meaning a new instance of the service object is created whenever the service is needed. Basically, each dependency injection will get a new instance of the service. And then between the two, there's the scoped service objects. Scoped means the same instance will be used throughout the processing of the same request. For example, in MVC, a request will first be processed by a controller, then the request will be forwarded to a view. If both the controller and the view need the same service, they will get the same service object. However, when a new request comes in, a new service object will be created. So, which service option should we choose when we register a new service? Well, singleton is the most efficient option because with only one instance of the service, because only one instance of the service will be created, we don't need to spend time creating then destroying lots of instances. The problem, however, is that because everything is using the same instance, the service code must be able to run correctly when it's used concurrently by multiple threads. This is not always easy to do. On the other hand, transient service is only used in one place, so we don't need to worry about code concurrency issue at all. The downside, of course, is that there's more overhead in creating and destroying objects. Generally speaking, if you are not quite sure, using scoped type would be a reasonably safe choice. But of course, it'd be best if you have a good understanding about the thread safety of your code and choose accordingly. Okay, now that we have the service registered with the service collection, let's see how we can inject it into a controller. The controller will use the employee service to get all the employees, then pass them to a view to display. So let's create the controller, and I'm going to create it under the controller folder, and select add controller, and we'll use an empty MVC controller. The name of the class will be called employees controller. Remember, the naming convention is the controller name plus the word controller. And here by default, it gives us a index method, which is good. We'll use it later. Now, let's add the code to inject the employee service into the controller. Employee service is the one that we registered here. So we'll do private read only employee service underscore e service. And then we'll create a constructor. And this constructor will take employee service and assign it to the employee service. So it's basically this code. Now, let's explain a little bit about what we just did. First, we declared a field called underscore employee service to hold the employee service that will be injected into this controller. Note that the type of the field is the interface type rather than the specific implementation type like mock employee service. By using the interface type, we will be able to use different service implementation without changing the controller code. We would typically also want to make this field private, so the service is only used in this class, and also making it read-only to avoid accidentally changing it. The underscore is a commonly used naming convention for private and read-only fields. I don't think it's a official convention, so you don't have to use it. But I see lots of sample code in Microsoft documentation uses this convention, so I usually use it. Now we have this field, and without dependency injection, we would have to say new some constructor to instantiate that object before we can use it. But with dependency injection, we can get an instance of it from the framework. All we need to do is just declare a constructor parameter here. The type of the parameter is used to locate the service in the service collection. So in other words, it should match the type here. And then when the framework creates a controller object, it will pass a service object to this constructor. This particular form of dependency injection is known as constructor injection, meaning that the dependency is injected through the constructor. Now, let's do the action method. So we'll use this index method here. If you remember, index is the default action method If the URL doesn't have the second segment, by default, the index action method will handle it, and it's as good as any method to use. So we'll use it here. And what we do is pretty simple. We'll simply call the employee service and call get employees to get all the employees. And then we pass the result, which is a list of employees, as a model object to the view. Now let's create the view. If you remember the last video, the view resolution works like this. The controller name defines the folder under the views folder where the view should be located. Because the controller is called employees, we're going to create a folder called employees here. And the view name will be the same as the action method name. So we're going to create a view, and this view is going to be called index. And the suffix is CS_HTML, which stands for C# HTML. We'll talk more about views later. So we'll have an entire lecture on the reserved views. For now, let's just do a simple example, and we'll explain it a little bit, leaving most of the details for later. So the first thing we need to do is to declare the type of the model object, because this model object is a list of employees. So we'll declare the model to be the type of a list of employees. And then we'll print out the employee information in a table. So here we'll create a table, and since the application uses Bootstrap, we'll do a class table, and then we'll create a t-head, and we'll say the first column is ID, second column is name, third column is date hired, and the fourth column is supervisor, something like that. And then we'll have a t-body, and inside t-body we'll have this for each loop. Okay, something like this. Again, details about reserved view will be covered in a separate lecture, but for now, just notice a couple of things. First, reserved view page is basically a mix of C# code, like for each, and XML, like table, t-head, tr, and so on. C# code is preceded with a @ symbol, like @ for each, then variable name, no model, and so on. And the HTML text is just written as HTML text. And secondly, when a view page takes a model object, the type of the model object is declared using @model, and then later the model object itself can be used in the page with a special variable named model with capital M. Okay, so now we have implemented an operation. Let's try it and see if it works. So to go to that page, we'll say employees, and we don't need to say index because index is a default action. And if we do that, we can actually see here, we get John, Jen, Tom, and Bob, and it actually works. Wonderful. Okay, now that we have the operation working with injected service, let's add EF core to the mix and replace the service implementation with one that actually accesses the database. So let me stop this one, and then let's add the dependencies. The first one is SQL Server. So this one, and we also need this one. Okay, so now we have the dependencies, and let's create the AppDB context class like what we did when we used EF core. So in a ASP.NET Core application, the framework will look up connection strings in app settings.json and create AppDB context instances for us. So the class actually only needs to have an empty constructor like this. So let's create that. I usually put the AppDB context class under services because it's also a type of service, and it extends DB context. And it needs to have a constructor that looks like this. And of course, it also needs to have the DB set employees. Employees. Okay, so this is our DB context class. Pretty simple. Notice that we no longer need to load the connection strings and do all that in here. That part is done in the service registration part. But in order to do that, we need to have the connection strings inside the ASP.NET app settings.json. So let me copy it over here. So the section has to be called connection strings, and connection name can be arbitrary. Usually there's one called default connection. And the server is cs3.constantLA, database 4540, STO31, CS4540, STO31, and password CD1234. Okay, something like this. Okay, so now app settings contains a string, and AppDB context is in place. Then the next step is to register the DB context as a service. Because DB context is a very important service, instead of using add singleton as scope and so on, there's actually a special extension method called addDB context for registering it. So let's grab this one and let's put it here. Okay. Looks a bit weird. Okay, now it looks better. Okay, so this will register FDB context as a service, and in particular, it will be registered as a scope service. This is kind of important because later on we'll create another service based on this service. Okay, now that we have FDB context as a register service, we could just inject it into a controller and do database access that way. For example, we could inject it into a controller like this and just put FDB context here and do database access directly inside the controller. But we are not going to do that. Instead, we are going to use this architecture where database access is behind a service layer. So why this additional service layer? Well, it usually serves two purposes. First, it allows us to have different service implementations. For example, in our example, we could have implantation of the employee service using in-memory list and another implantation using the actual database. We wouldn't be able to do this if we inject FDB context directly into the controller. Another common purpose of the service layer is to put the so-called business logic into the service layer instead of doing it in controllers. The benefit is that the service layer can then be scaled separately from the web layer, and the same services can be used to support different types of applications. Here's a quick example showing the difference between the so-called business logic and just data access. Suppose we want to create an object. It's not as simple as create a project. It's not as simple as create a project object, then save it to the database. By the way, the project I'm referring to here is the project in the company example with companies that in that example, a company has employees and projects have leaders and members and so on. Suppose we want to create a project in that example. First, we need to make sure the project name is unique. And secondly, if the project has a leader, we need to make sure the leader is also added as a member of the project. So this type of things are the business logic. They are the kind of processes and requirements that are beyond just getting and saving data. And this type of things are typically done in the service layer, in service classes. So now with that, let's implement the real employee service. So we'll put it in the same file here. And so we'll say employee service, and it implements this interface. And just like the controller, we'll need to have something injected in here. And then that something will be a FDB context because we need that to access the database. And similarly, we'll create a constructor that takes FDB context and put it here. Now, once we have that, then getting employees becomes simply db employees to list. Okay, so now we have the real employee service implementation, and let's replace it. Let's replace the mock one with the real one, something like this. Now here is there's an issue here. Previously, we are using a singleton lifetime service because our Mock's employee service implementation has no concurrency issue at all. So one single instance is enough for everything that needs to use it. However, we cannot use a singleton for employee service. The reason is because this employee service has its own dependency, which is the FDB context. And as we just mentioned, FDB context is a scoped service. We should not have a service with a longer lifetime depending on a service with a shorter lifetime. That situation is known as captured dependency. And it's bad because the service with a shorter lifetime will live longer than it should be. So in our case, because FDB context is scoped, this employee service should be scoped as well. Okay, so I already created the table in the database. Let me so here it says John, Jane, Tom, and Bob, and so on. And we have replaced the employee service. We didn't change any code in employee controller, and the employee controller now should get the new employee service that get data from the database. Let's see if that's the case. And if we go to employees, it indeed works. And the data is the same as before. Just to make sure that we're actually getting data from the database, let me change something in the database. So let's say instead of John, we'll say Jack. And if we come back and refresh, it shows Jack, meaning that the data now is indeed from the database. I want to show one more thing with this example using include. So right now it works, and if, however, we try to So instead of the supervisor, we show the supervisor name. Let's say we say supervisor.name. We are going to get an exception because, well, because some employees doesn't have a supervisor. So let's change this a little bit more. Let's say if employee supervisor is not null, we display the employee name, something like this. Employees. Okay, so yeah. So this one actually shows the supervisor name and did we use include? Where is the employee service here? Oh, we don't even need to use include. That's great. So in here, what I wanted to show is to use include to load the supervisor. But I guess even by default, it loads not only the supervisor ID, but also the supervisor object. So we don't even need to use the include. That's great. Later, if we do need to use include in some other cases, we'll come back to this. Okay. Okay, so this is the end of this video. Middleware and middleware pipelines are covered in Chapter 3 of the ASP.NET Core in Action book, and dependency injection is in Chapter 10. So please check them out. Thanks, and see you in the next video.